I've got a puzzle for you about making the biggest possible area, but I want you to try and answer it with your intuition first. Yes, by all means, then try and put numbers on it and make sure that your intuition is correct. But the first way I want you to try and solve it is by having to think about what shapes and what sizes that are gonna give us the best area. So let's start off with a slightly easier puzzle, and then part two is a bit more tricky. So we have 60 1 centimeter sticks or lengths, and we're going to arrange these, but you can only connect them at 90-degree angles. And the idea is to make the largest area you possibly can. Okay, that's it. That's all you have to do. Now, have a little think about that. Pause the video, have a little think about it. See if you get the right answer, even if you just think of the right shape without doing the maths and working out what the actual area is. What shape are we looking for? Okay, pause the video now. So, what's the solution? If you said this, then obviously you're completely wrong, because anything that's concave, we can just turn these this corner outwards. We can move this vertical bit over here, and this horizontal bit, we can put that up there, and we get a larger area. We get to claim all this area from the same perimeter. And likewise, we could turn this bit here. We could have this sticking out like this, and have a much bigger area. And also, then we'd have a little turned-in corner here we could turn out, and one down at the bottom as well. So anything that's concave is going to be useless. You can always fold it out. We're going to want something that's convex. And if we weren't tied by the 90-degree rule, then we'd have a circle. That would be the absolute best. It would contain the most area inside a circle. But as we have to have it 90 degrees, then the correct answer is a square. So if you got that, well done. If we just do the numbers to get the actual answer, divide the 60 up by the four sides, it's 15 centimeters a side, so the area is 15 squared, 225 centimeters squared. Well done if you got that as well. Let's look at the slightly harder part of the puzzle, which is this time we're going to make the same thing. We're going to try and make our biggest area, but we're going to make it up against this straight line, or a wall if you like. Okay, so you're getting this side of the rectangle for free. Same size, a perimeter, 60 centimeters, but obviously only needed for these three sides, because you're getting this one for free. And you can use as much of that as you like, or as little as you like. It's just a big, long wall, and you can use as much of it as you like. Still 90-degree corners. Okay? Again, pause the video. If you don't want to actually work out the numerical answer, again, what is the shape that we're looking for? If you said a square, then you probably thought that it would be 20 by 20, because obviously we only have to divide 60 by the three sides, and you therefore said that the answer is 400 centimeters squared, then you are wrong. And for me, this is also what I said. I said, yes, the area, just like before, we've got to maximize the area, and we'll do that by making it as circular as we can. And because of the 90 degrees, a square is as circular as we're going to get. But what I didn't consider, and what perhaps you did or did not consider, depending on how you thought about this, is the fact that we're getting this side for free. So before, when we had to spend all 60 on each of the sides, then it was best to have it as a square. But when we've got that side for free, it is better to stretch it out slightly. So here I've made it just slightly longer and slightly shorter. And this time we're getting more perimeter. If we have more perimeter, then we've got more ability to contain area. We can contain more area because we've got more perimeter, because we're then using 2 extra centimeters of our wall than we were last time. And you can see that 22 times 19, we've already beaten it. But if we take that too far, if we go all the way to having a really, really long rectangle that's not very tall at all, then it doesn't help. We've gone too far the other way. It's only it's 1 centimeter tall and 58 wide, and it's only an area of 58. So there is some balance in between. So what is the perfect balance? And this is the bit that that I found difficult to get intuitively. And if you've got an intuitive explanation as to the answer, then I'd really like to see that in the comments below. The answer is a double square. So you can see here that the width is twice the length of the height. And this is not just true for this question with 60 centimeters. It is true any time that you are making a shape and maximizing the area up against a wall. The best answer is going to be a rectangle that is twice as wide as it is tall, or a double square. You split this down the middle and get a square. Now you can show this algebraically, you can show this graphically, and you can prove this yourself, but intuitively it's not so obvious. And I think what this puzzle showed me when I saw it, and I sort of naively said, oh yeah, the answer will be another square, and I got my 400 and I was feeling pretty confident, and then I got it completely wrong. What it reminded me is that the first thing you think of, and what may be completely sensible in one context. So when we had the first question where we were having to pay for all 4 sides out of our 60, yeah, that made sense. And my knowledge of that as circular as you can make it is going to hold the most area, that was great. But when the situation is slightly different, there are subtleties that you have to stop and think about, and diving straight into your gut reaction and not checking carefully what the implications are is not always a good idea, because then you end up getting it wrong. So, did you get this question right, or did you fall into the same trap I did? Let me know in the comments below. That's all for today. See you next time.